Hi, it's Dr. J here. In this video, we will be working through a WACE question from 2021 involving relativistic momentum, energy, and relative velocity. It was question 18 from the 2021 exam. In an experiment, two neutrally charged subatomic particles A and B, each of mass m, are fired directly towards each other. Both have a speed of 0.6 c as seen by the observer O shown in figure 1. The particles collide and become one particle, which O observes to be stationary. No energy is lost due to interactions with the environment and no other particles, e.g. photons, are emitted. You can see the diagram that's there. The fact that no energy is lost due to interactions implies that it is an elastic collision. Part A. Using conservation of relativistic energy, calculate the mass of the combined particle MC. Give your answer in terms of m, the mass of each of the original particles. Let's start by writing some information down. So the particles MA equals MB is equal to m. We have an initial velocity for particle A of 0.6 c to the right. VB will be negative 0.6 c to the right because it's going left, and the velocity of c is equal to 0. So we're using conservation of energy, and from our formula and constant sheet, relativistic energy is written as such. Okay, don't worry, a lot of this stuff will cancel out. So let's pop some numbers in here, or some information that we have. So MA is equal to M, we have C squared, we have square root of 1 take 0.6 squared, that will be C squared over C squared, so that will cancel out, plus MC squared, and again we've got the same term here. So notice that negative makes no difference in this particular part of the problem. Notice that V of the particle is equal to 0, so this term at the bottom becomes equal to just the square root of 1. So now I have 2mc squared over, now what we should do is 1 take away 0.36 is equal to mc squared. So these c squareds cancel out. So then we find out, if we pop that through our calculator, that mc is equal to 2.50 m. Part B. Explain why the velocity of the combined particle has to be 0 meters per second. So this will relate to the conservation of momentum, of relativistic momentum. So this is the conservation of momentum, Okay, so write an equation if you can. Sum of P before must equal the sum of P after, and that's just that idea about that elastic collision that I mentioned before. And then you know that it's going to be m times v before is equal to m times v after. So since the masses are equal and the velocities are equal but opposite, so one is the negative of the other, the sum of P after must equal 0, therefore velocity of particle C must equal 0. So that's how we know. Okay, so 2 marks, generally 2 points, but this here would be considered to be 1 point, and then you've got your second point there. Okay, part C and D. For part C and D, consider the same collision viewed by an observer X who is moving with a velocity of negative 0.6 c, i.e. the same velocity that particle B had before the collision. X maintains this velocity after the collision. So using the formulas for relativistic velocity addition and relativistic momentum, determine the momentum of the system before the collision as determined by X. Express your answer in terms of m and c, the speed of light. So what we need to do is we need to figure out the velocity of A as determined by X. Okay, so let's consider this to be the observer, because again we know the velocity of A and the velocity of X with respect to the observer, or O. So let's do that and then make this 1 and this object 2. So if I've got this as object 1 and this is object 2, okay, then let's do our defining of our variables. So I've got U, V and U dash. So U is object 1 with respect to the observer. V is object 2 with respect to the observer. And then U dash is object 1 with respect to object 2. And then that way you can see, okay, we're going to end up with that velocity of object 1 with respect to the observer X. Okay, so object 1 with respect to the observer is 0.6 c, and that's going right. V would be negative 0.6 c right, and we're looking for this one here. So U dash is equal to so from our formula and constant sheet, U take V, 1 take V times U over C squared, and then let's pop in our numbers. So 0.6c, take away the negative 0.6c, divided by 1, take away 0.6, negative 0.6 c squared over c squared, and that leads us to 0.882 c. So this is the velocity of A as observed by X. Right, next thing that we need to do is to determine the momentum of the system before the collision as determined by X. So we're looking at P before is equal to PA plus PB, and this is observed by X. So we've got MV over the square root of 1 take away V squared over C squared. Now you might be wondering, what do we do about PB? Well, particle B is moving at the same velocity as observer X. The relative velocity between the two of them will be equal to 0, so that's going to be equal to 0. So let's just write here as observed by X. All right, so let's pop those numbers in. So I've got the mass times by 0.882 c divided by the square root of 1 take 0.882 squared. Then I have c squared over c squared, and that gives me 1.87 mc. Part D. With the use of a calculation, show that your answer in part C is the same as the momentum of the system after the collision as determined by X. So here we have particle C, and here is our particle X. Particle X is moving at 0.6 C, and that will be with respect to C itself, because C, remember, is stationary with respect to the observer O. So P after is equal to mc times by the velocity that X is with respect to C. Let's pop those numbers in. Oops. And we have that the particle C is 2.5 m from before. Its velocity with respect to X is going to be 0.6 c. And if we pop those numbers in, we end up with 1.87 mc, as we expected from part C. So that is question 18 from 2021 paper concluded. So in this video, we use the equations of relativistic energy, momentum, and velocity. An important part of doing this question is to read the question carefully, because it gives you hints as to how to approach the question, even though it might have looked a little bit tricky to begin with. Thank you for watching my video. Please subscribe to Dr. J's channel for the latest physics tutorial, and if you have any suggestions for things that you would like me to do a tutorial on, please write them in the comments. Thanks a lot.